There you go. Okay. All right. So everybody know what inorganic nomenclature means? So we're going to learn to name and write formulas for thousands of compounds. Remember that chart that had matter and remember mixtures? Remember that? The box we started at was atoms, ions, isotopes. Now we move over to another box called compounds. Get that? And then later we'll go to one called solutions. All right. What I did is I divided up, and I really wish somebody would have taught this to me in high school. Because here I went to college, and they made me take a lot of chemistry, a lot of it. And I had not had this lesson. And I had to struggle with it. It was difficult for me to write formulas. I didn't know there was a method. There was actually a method you can teach somebody how to do these. So if you'll stay with me, okay, and can it be enthusiastic? Think you can do that? Okay, be enthusiastic. Here we go. Type 1 is the easiest ones. And tell me if type 1 means what? What kind of compound is it? What's that mean? Only 2 elements. What's this mean? And if you're looking at me and saying, am I supposed to remember that? Well, how about read it? Can you read it? So it means you have a metal and a non-metal, right? And what's the third thing? What's the third criteria? The metal has to be a what? Always metal. I made that up, okay? If you get a PhD in chemistry, you don't have to use that word. I made it up, okay? It's not really found in any books. I call them the always metals. All right, where are the always metals? I bet Lauren knows. Ready? Lauren, which one's the always metals? Group 1A, and they always form what kind of ion? Yes. Go ahead. Yes. And they're +2, and then there are 3 more. And what charge? Excellent. Excellent. Everybody got that? Now, does everybody know the always metals? So, if I were to write one for you, let's write one. Al. Let's form a compound between Al and S. Is this binary? Is this going to be binary? Is it a metal and non-metal? Yes. Is it an always metal? Yes. Aluminum, yeah, isn't it? So we can do it, right? And what is aluminum always form? What was it always? What? Not +1, not +2, but okay. I'll put a little +3 here. Now let's do the non-metals. Remember that we're not going to be looking at the noble gases. They don't like to form compounds at all. So these are -1, -2 ions, and -3. Can everybody remember that? All right. So what are you going to put above sulfur? -2. Okay. Now, ready? All compounds have to have a net charge of 0. And what's the smallest number that these both go into? 6. And what times 3 is 6? And what times 2? All right. We actually have a compound here because see, +6, -6, don't we? Now, how do we name it? How do you name a type 1? You say the name of the metal, say it, aluminum, and you don't say sulfur, you say what? Sulfide. All binary compounds end in what? IDE. Now, let's see, what else do you not know? What else do you not know? Yeah, I guess that's it. Okay, also, ionic compounds, you would never have 4 and 6 here. It would always be reduced to the lowest whole number ratio if it's a type 1. You get that? All right, pretty easy? All right, so that's how you write formulas, and that's how you name type 1 compounds. What do you think? All right, can I do one more? If you do one more and if everybody in the room gets it right, I think we're ready to move on. All right? And I'll call on somebody at random. How about that? What's the most likely compound to form between zinc and fluorine? And notice I picked a metal and a non-metal. I picked one of the always metals. So what I want you to do is write the formula and then write the name out to the side. Write the formula and write the name. Now we should be getting, you'll be getting faster and faster in these, okay? And type 1 is kind of the easiest one. So, all right. All right, who can I, Dave, can I pick on you? All right, ready? What do you, in a compound, what's the charge on zinc?
Zinc, +2.
It's always +2 for zinc, isn't it? What about fluorine?
-1.
Minus what?
-1.
Yes, that won't work because all compounds have to have a net charge. So what are you going to do?
2 fluorine, 1 zinc.
Yes, so ZnF2, right?
Yes.
Now, in the real world, you don't write these in the formula. And I don't mind right now everybody writing the little charges. Okay, you got that? So your final answer would be ZnF2, right? So that's what it looks like. Now, Dave, what's the name?
Zinc fluoride.
Yes. Now, here's why I have to caution you a little bit, okay? Some of you right now are thinking, this is so easy. Wait, this is just type 1, isn't it? If you understand type 1 really well, then you'll be okay when I go to type 2. You get it? But it gets harder. Okay, ready? You ready to do type 2? All right, now watch. Type 2 is what? Whoa, wait a minute. That's the same as type 1. Type 2 is what? What? What's the same? And what's the only difference? Not one of the always metals. You get that? Oh, by the way, I forgot to say, let's go back up here again. Remember, for type 1, you do not look at the subscripts to name it. This is just called what? I don't care there's a 2 and a 3 here. What's it called? Aluminum oxide and zinc fluoride and barium. You got that? I forgot to mention that. Okay, now, so type 2 is just like type 1, except it's not one of the always metals. Now, I'm not God, but I know when he made his Tinker Toy set here, and I used to use that word, and I found out that a lot of people your generation, they don't know what a Tinker Toy is. Raise your hand if you do know what a Tinker Toy is. Okay. How about Legos? When he made his Lego set, a Tinker Toy is a building set, and some of them have long sticks in there, and they have little spokes. You put them in there, and you build things. I'm going to stop using the word Tinker Toys, because somehow your parents are not buying Tinker Toys anymore. All right. Go look it up, Tinker Toy. Okay, here. So God, when he's going to make some more variety, he wants to make variety, and especially in the transition metals. Look at the transition metals. If you're any kind of an artist, you know that there's a huge variety of paint colors, aren't there? And many of them have the names of transition metals. Cobalt blue, titanium white, right? What's another one? What's yellow? Chromium yellow, something like that. The transition elements actually do different things. They don't do the same thing all the time. So let me show you something here. Here is Fe2O3. And here is FeO. Now, if these were type 1, what would you call this one? Let me call on Ryan. Ryan, if this was a type 1 compound, hey Ryan, if this is a type 1 compound, what would you call it?
Oh, sorry, you're asking me a question.
Yeah. If this is type 1, let's pretend it's type 1 for a minute. What would you call it? Name.
Ferrous oxide.
Oh, well, I haven't taught about ferrous or ferric yet, so let's not do that. How do you know that?
Because it's iron.
Okay, just say iron then, for right now. We are going to use
Oxide.
iron oxide. Now, what I want you to do is write iron, leave a space, and write oxide. Now, Ryan, tell me the name of this one.
Ferrous oxide.
Oh, no, don't use the ferrous or anything yet, just iron. I will teach that,
Oh,
but...
they're both just iron oxide.
Whoa, we have a problem. They're both iron oxide. Now, can I show you something? If they always metals, that never happens. It never happens. There's only one kind of sodium chloride. You get that? But how many kinds of iron oxide are there? 2. So, chemists had a problem, didn't they? How are we going to name? We don't want to say iron oxide. Say, which one? So here's how they did it. Ready? Here's the only difference when you name these. Ready? All right. We have to do a little more work. What's the charge on oxygen in a compound? We got to be a little faster in this. -2. Now, if the whole thing's got to be 0, then iron must be what? +2, right? Now, look at me. This is simple. It's simple. We have to use a Roman numeral. This is called the stock naming system, or the Roman numeral system. And what I'm going to do is I need a way to figure out which is which. So you take the charge on the metal, and turn it into a Roman numeral. And so what's the name of this stuff now? Iron what? Iron 2 oxide. Now let's look at the next one. Ready? What's the charge on oxygen in this compound? Got to be a little faster. -2. And what is this now? What's 3 times -2? -6, right? This has to be +6. 2 times what gives you +6? All right, now see that Roman, what are you going to put here? What are you going to put here? That's it. Now again, I did not look at the subscripts to name it, did I? But did I have to figure out the charge on the metal? If you find the charge on the metal, then you put a Roman numeral. You will never use Roman numerals for type 1. Why not? How many ways can you make barium chloride? Once. That's why you don't need it. It's barium chloride. How many ways can you make iron chloride? 2. I have to tell you which one's which. Now we're going to practice this again, right? Let's try another one. I happen to know. Let's try this one. Copper 1 chloride. Copper 2. It just so happens that copper comes in 1 and 2 chloride. All right, write the formulas. Write the formulas for copper 1 chloride and copper 2 chloride. And this is the first time you've ever done that in your life, probably. You got it? Wow, that's fast. Is that what you had? Okay, now, watch now. Copper 1. What's the Roman numeral stand for again? The charge on the, say it, on the metal. So this is copper +1. That's what it said. And chlorine's -1. That's going to work. So what is the formula for copper 1 chloride? CuCl. Let's do the next one. Copper 2. Oh, did you say copper 2? Copper 2? Okay. Okay, and let's do chlorine. Uh-oh. That's not going to work. So what we're going to do here. I need another chlorine, don't I? Everybody get that? Does that make sense to you, putting 2 here? Because if each chlorine's -1, I have 2 of them. Won't that be -2 and -2 and +2? What do you think? Okay. All right. Let's go down. Let's try another one. What is the name of this? All right, see if you can figure out the names for these 2 compounds. Does everybody remember SN? It's a weird one because, what is it? It's only 3 letters long. The whole element's only 3 letters long. Tin. Excellent. Tin. All right. So are you going to help me on this one? Now, if you're not sure, then I called on the right person. If you're sure, it's going to sound good anyway. So tell me what are you going to do here?
So, wait.
We're going to name it.
Okay.
Now, I'm going to show you a little trick here. Ready? Can you name this and pretend it was a type 1? How would you name it if it was a type 1?
Like, 10I?
No, not the ID. The IDE never goes on the metal. It goes on the non-metal. So
Alright,
10
oxide.
oxide, okay? Now, all I want you to do is leave a little space here. We're going to head and write tin oxide, okay? And let's go down here and write tin oxide for this one. Okay, now we have to have a little more work. Because he's not always metal, it's a little more work. All right, what is the charge on an oxygen in a compound? What is it? Let's try it again. This is +1, +2, +1, +2, +3. These are what?
Negative.
-1,
Negative 2.
-2, -3. Okay, so what's oxygen?
Negative 2.
-2, right? But how many oxygens do I have?
2.
2 times -2 is what?
4.
And the whole thing, all compounds have a net charge of 0. If this is -4, then you must be what? You're +4 all by yourself, aren't you? Everybody with me? So now, what's the Roman numeral goes here? It's always the what? The Roman numeral is always what? Charge. Who said that? Charge on the metal. Yes. 10, 4. Now, so you do the last one for me. 10, 4 oxide. What's this one?
It would be negative. The charge for oxygen would be -2.
Yes.
It would be +2.
Yes.
For 10, and then that equals 0. So it'd be the Roman numeral would.
So what-
Roman numeral would be 2.
And what's the name then?
10, 2 oxide.
Excellent, excellent, excellent. Everybody got that? Now, remember, you will never use a Roman numeral for type 1 because they always form the same. I didn't do it. God said, I'm going to make iron be +2 sometimes and +3 another time. I didn't do it. Look at tin. I'm going to make you +2 or +4. See that? All right. Are you okay with this? Keep looking at you. Okay. Now, there's parts of type 2 I'm not willing to teach yet. I'm going to come back and teach this guy here. You probably want to know what that's all about. Do you think you're ready to learn that right now? I guess I could do that. All right. What happened is this Roman numeral or the stock naming system was a great thing that they did, chemistry. But they didn't start out that way. They did not start out writing compounds that way. They thought they had a neat system, and then the more they discovered, they said, oops, our naming system, it's got some flaws to it. And so I wish I didn't have to teach the old naming system to you. I wish I didn't. But guess what? If you go to college, they're going to use both systems. If I have to order, you know what, I have to order chemicals here sometimes, and I have to look in a catalog. If I don't know both systems, I won't be able to order the right chemical. And the professors you have, guess what? Their professors taught them both systems. See that? It's just the way it is. So anyway, let's go over here, and I'm going to show you that there was an old system, and it was called it was using Latin, like you did. You used the Latin word for iron, and I call it the IC-US system. The IC-US system. Now, let me show you how this works, all right? Let's go down here to the bottom, and let's take a look at this compound here. All right, what would the name of this be? And oh, what's the name of this going to be? Without looking. Lead 4 oxide, is that correct? And what's this one going to be? Lead 2 oxide. Okay, so we understand that part, don't we? Now, the old number system, before they started using the Roman numerals for it, they used the Latin word. What is the Latin word? Okay. Anyway, by the way, what I'll do is on the test, I will give you a periodic table and it will give you the Latin words. So what is the Latin word for lead? It's plumbum. Okay? You got that? Now, I will give that to you. But what we have to do is, I don't want to call them both plumbum oxide, because that's confusing, isn't it? So here's how I'm going to teach you to do it. All right? It's called the ick and the us system. See this guy here? He's the big, icky monster. He's the big, icky monster. Now, see this guy here? Lead 2, lead 4. Which one's big? 4. Then he gets to become what? The big, icky plumbic. You get it? And what about the smaller guy? He can't be plumbic, but what can he be? Everybody see that? Yes? Okay. So, anyway, what is this called? This is called lead 4 oxide. What's the old naming system? Plumbic oxide. Now, I was kind of impressed when you actually even used the word ferrous, because I hadn't taught that. Let's go way back up here now, and let's name them with the ick and us system. And I will tell you that the Latin word for iron is ferrum. And by the way, you know that plumbum, PB, see, plumbum, get it, PB. And do you know there was a college called Ferris State? There's a college called that. And guess where they made all their money? Iron mines. Get it? Ferris? Okay, all right. Anyway, so now, ferrum's the Latin word, and here we have iron 2 and iron 3. Who's the big, icky monster? 3. 3's bigger than 2, isn't it? So he's going to be called what? Ferric. Ferric what? Oxide. And what about the little guy? Ferris Bueller. No, that's a movie. Have you heard of that? Ferris Bueller? Okay. Kind of a weird waste of time movie, but it's a classic. Everybody knows it. So he takes a day off of school and he steals his dad's car and he does all kinds of stuff. So what do you think about the ick and us? Okay, now let's go ahead and name this one. I will tell you that the Latin word cuprum is Latin for copper. Now you know why Cu is the symbol for copper. All right, who's the big icky monster here? 1 or 2? 2 is icky, so what are you going to call him? Big cupric, what? Chloride. And what about this guy here? Cuprous. Chloride. Woohoo! What do you think? What do you think? So, type 2 is actually like type 1, except we have to put a little extra work into it to figure out, are you iron 2 or are you iron 3? Yes. Yeah, thank you. Seems like they have more than one passing period, don't they, in a 45? Sometimes it's like, wait, weren't you making noise 5 minutes ago? All right, I'm going to relax a little bit. I'm going to look at your eyes, and you're saying, right now, all of you could write formulas and names for almost 1,000 compounds. Now, I would have to help you a little bit. For example, I don't memorize all of them, but up here, I can look up iridium. I almost never use iridium. But if I look on a periodic table, there's a +3 and a +4 there. That tells me that iridium can come in a +3 or a +4. Now, I don't memorize iridium because I don't use it very often. See that? And so you can take look at vanadium. Vanadium +2, +3, +4, +5. See, at first, chemists probably thought, I bet there's only 2 kinds of vanadium, so we'll call one of them ick and us. Then what happens when there's 5 kinds? Well, what are you going to do now? Ick and us, you run out of things, don't you? Then they went to the Roman numeral system, said, vanadium 2, vanadium 3, vanadium 4, see that? And that made sense. All right, now, I'm going to flip the page here. Here we go. Now, I want you to pay attention here because you have an assignment for Friday, and it's different. I'll tell you what we're going to do. I want to show you about type 3. All right, first of all, type 3 is not binary. It has at least 3 elements in it. Get that? So I'll call it ternary. So it's not binary. It's not binary. There's more than 2. Okay, now I'm going to give an example one, ready? Okay, now, a person who had never been in chemistry class would call this sodium nitrogen oxide. But that's not it. But I have some really good news for you. I have some really good news. If you have more, look at this, here's one element, and here's one element. See that? See that? I have some good news for you. If you have more than 2 elements in the compound, good news number 1, it contains a polyatomic ion. And a polyatomic ion, you know what poly meant in biology class? Like polypeptide, polysaccharide.
Multiple.
Many, multiple. Very good. Now, polyatomic. Many atoms that together act like an ion. Polyatomic ions. Now, see this guy here? It had more than 2 elements, right? It contains a polyatomic ion. Good news number 1. Good news number 2. Somebody else has already named the polyatomic ion. Get that? And good news number 3, you will never change the name of a polyatomic ion. So, if you'll take this sheet here and look on the very, very back. Look on here. This. Guess what this is a chart of? Polyatomic ions. Now, so I'm going to show you how to do the first one, then I'll tell you what your assignment is, all right? I'm going to go find that thing. What we're looking for is a thing that looks like NO3. And does anybody happen to know what charge it's going to have? If sodium is +1, then what's well, I didn't give them yet. What's the charge on this polyatomic ion? -1. So let's go find in the -1 column. Oh, here, look. Here's the -1 polyatomic ions. Here's the -2s. Here's the -3s. Here's the +1s. Okay, can you find it? NO3 with a -1 charge. You find it? Oh, yeah. What's it called? Nitrate. Now you're not going to believe this, how simple this is. Ready? What are you going to call this now? Sodium. And what's this called? And you never change the name of a polyatomic ion. What? What? That's it? That's it? That's it. I keep looking at your faces, and you're probably thinking, wait a minute, that's too easy. You want another one? Let's do another one. Does this have more than 2 elements in it? So what does that mean? If it has more than 2 elements, what's it have in it? A polyatomic ion, isn't that right? Matter of fact, I know that each potassium is +1. I have 2 of them. If this is +2, I bet this guy must be -2. Let's go find him. Go find that guy in the -2 column. What is the name of SO4, the -2 charge? Sulfate. What are we going to call this then? What do you think? Potassium sulfate. All right. Now, yes.
How did you get the 2 for potassium?
Okay, at this point, I wrote it out. I'll show you how to write the formulas, but let's just pretend I wrote it correctly, okay? And I did. The fact that this is this whole thing, see my fist? if that's sulfate, and sulfate's -2, what does this whole thing have to be? +2. But potassium's only +1. So don't I need 2 potassiums? What's +1 and +1? That'd be +2, right? And that would make the net charge 0. Now, don't forget, let me show you this now. Try this one. All right, try this one. Does that have more than 2 elements in it? Does it have more than 2 elements? It has iron, carbon, and oxygen, right? So it must have a polyatomic ion in it. So go look for this thing right here. Go look for that. See if you can find it. Anybody having to find it yet? Okay, so what are we going to write here? Iron, leave a space. Leave a space. Iron, leave a space, what? Carbonate. Now, why did I leave a space? It's not an always metal. There must be more than one kind of iron carbonate, right? Is he an always metal? Is iron an always metal? No. All right, so what's the charge on carbonate? -2, right? Then what's the charge on this iron? +2, right? So what's the Roman numeral going to be? Oh, I can do that. What's the other name for this? Iron comes in +2 and +3. See the big icky? So what's the other name for it? Ferrous carbonate. Okay. All right, so what I'm going to do is, that's enough for today, except, wait a minute, I'm going to give you an assignment. I want you on Friday, I want you to make flashcards for these polyatomic ions. Now, they have to be color coded by charge. So, let's say there's more -1s than any other kind, aren't there? What's your favorite color? We're going to call one. Lalani. What is your favorite color? Blue? Okay, so she's probably going to make all these blue. Now, here's what you can do. You don't have to go find blue flashcards. You could just take a marker and either put a blue thing here or here. You could put a border of blue. So let's pretend that you made this blue, okay? That means everybody who's -1 is going to be on a blue flashcard. Now, what's going to be on one side of the flashcard is going to say something like this: NO3 with a -1 charge. Everybody get that? And what's going to be on the back? Nitrate. Now, they've done a lot of science studies that color helps people memorize things better. I also have games we're going to play to help you memorize these polyatomic ions. Okay, you got that? So, you've done a great job. You've done a great job so far. You have type 1, type 2. As a matter of fact, you have an idea of type 3, don't you? All right, so you can go home and you can make these first and then start working on your Pacto a little bit and